In this video, we'll be talking about how to order the real numbers using inequalities and intervals. We call a number non-negative if it is positive or zero. This is because zero is not considered a positive number or a negative number. Now, a neat feature of real numbers is that you can also graph them on a number line. This is also called plotting. A quick note, 0 is also called the origin. And as far as an example goes, let's plot these real numbers on this number line. So, for instance, negative 7 over 4 is, so if you consider that negative 1/4 is here, then negative 7 over 4 would be about here. It can also be helpful to note that negative 7 over 4 is the same thing as negative 1.75 as a decimal. 2.3, meanwhile, would be about here. 2/3 is about here. And finally, negative 1.8 is actually very close to negative 7/4, but it's going to be a little bit bigger. So right in there is negative 1.8. Here's an example for you to try. Plot the following real numbers on a number line. Again, I encourage you to pause the video and try working this out before I give you the answer. If you've worked it out, here is the answer. Additionally, real numbers can be ordered with inequalities. We write A is less than B to mean A is to the left of B on a number line. That is, we would have something of the form A could be here and B could be here. On the other hand, we say A is greater than B to mean A is to the right of B on a number line. That means B would be here and A would have to be greater than it. Additionally, we write A is less than or equal to B to mean A is less than B or A equals B, and A greater than or equal to B means A greater than B or A equal to B. For some examples, we have that negative 11 is less than negative 5, 1 is greater than negative 5, 3/2 is less than 7, negative 2/3 is greater than negative 3/4, 3 is less than pi, 3 is thus also less than or equal to pi, 3 is less than or equal to itself since it is equal to itself, and 3 is also greater than or equal to itself since it is equal to itself. Another useful thing about inequalities is inequalities can be used to describe subsets called intervals. These are best understood with a number line. This is a lot of information, so let me go through this. We use this notation, the bracket notation, to denote closed intervals. Closed intervals are any intervals that contain their endpoints. In this case, the endpoints are called A and B for each of these. Because it has numbers for both endpoints, it is considered a bounded interval, and that goes for all 4 of these. Open intervals do not contain their endpoints. And as such, this inequality, to represent this, is A is less than or equal to X, which in turn is less than or equal to B. And when graphing this, we draw it this way using brackets and shade in between so that it becomes obvious that we are including both endpoints. For open intervals, we do not include the endpoints, which is to say A is less than X. X cannot be A and X cannot be B, but X is still less than B. Here, we use parentheses to denote the fact that we do not reach A or B. We can also go one at a time and mix and match. So X is less than or equal to A, but less than B, and here X is greater than A, but less than or equal to B. And we still use our parentheses and our brackets as appropriate. Moving on to unbounded intervals, we say an interval is unbounded if it has only one endpoint. In this case, we use this symbol infinity to denote the fact that we just keep going on and never reach another endpoint. So here, we start at A and include it, so x is greater than or equal to A, but then it just never ends. So while we start at A, we just keep shading forever. Similarly for open. We can also do this the other way. Oh, and that's x greater than A. Similarly, on the other end, we have that x is less than or equal to b, but we just keep going down the other direction. And similarly for open. Now, we could also write the entire real line by using the notation negative infinity to infinity, which would just be to shade in the entire real line. Thus, in this way, by using this notation, we can actually use either inequalities or interval notation interchangeably. For example, the inequality x less than or equal to 2 denotes all real numbers less than or equal to 2. This interval, however, consists of all real numbers greater than or equal to 2. But that's all we say because we know that there's no upper endpoint to this. We also have that inequality that represents all x in the interval negative 3 to 5, in this case, would be start at negative 3, we're greater than it but not equal to it, and still less than or equal to 5 because of the bracket. Graphing this would thus look like again, keep in mind that infinity and negative infinity are not numbers. Rather, they represent a place bigger than any of the numbers between them. And again, I have one more example for you to try out. Again, go ahead and pause the video and try it out. Once you're done, go ahead and unpause the video and I'll give you the answer. If you finish, the answer is here. Now, a few last helpful hints for this is that closed intervals contain their endpoints, open intervals do not. You also cannot reach positive infinity or negative infinity, so it is always going to be open at those quote-unquote endpoints. For more practice in ordering the real numbers, be sure to look at the Ron Larson's text, page A11, numbers 2 and 11 through 28. And in our next video, we'll be talking about absolute value and distance.